This is question number 12 from homework section 9.2. A 500-pound object hangs from two cables with angles below the horizontal of theta equals 35 degrees and phi equals 37 degrees respectively. Determine the magnitudes of the tension vectors T1 and T2. So we have a little diagram here. I'm going to redraw a diagram. Here is the 500-pound object. We have a cable there and a second cable there. I'm going to label this T2. I'm going to label this T1. And it turns out that there is a third vector, and that is the force of gravity that's acting upon the 500-pound object, and I'm just going to label that T3. And because that object is not moving, it turns out that when you add up all of the tension vectors together, their sum results in the zero vector. So that is another way of saying T1 plus T2 plus T3 should equal 0, 0 like that. So we are going to use the fact that the sum of the three vectors equals the zero vector, but we want to write each of the vectors in component form, and to do that we're going to need some angles. Now, I'm going to draw a horizontal line here in order for us to figure out some angles. I know that phi here is equal to 37 degrees, and if I drew a horizontal line here, that would make this 37 degrees. So this angle here is 37 degrees, and we also want to figure out this angle here. We know that theta is 35 degrees, and that's based off geometry, that's going to make this angle 35 degrees. So if we subtract 35 degrees from 180 degrees, that's going to tell us that this angle here is 145 degrees. So let me just redraw that here on this diagram, 145 degrees. Now that's going to help us write each of the vectors in component form. So T1 I will write as the magnitude of T1 times cosine of the angle that's associated with T1, which is 37 degrees. And then the other component is going to be the magnitude of T1 times sine of 37 degrees. And now we can write the component form of vector T2, and that's going to look like the magnitude of T2 times cosine of 145 degrees, and the other component would be the magnitude of T2 times sine of 145 degrees. And then T3 is going to have the components 0 because there's no horizontal component, and then it's going straight down 500 pounds, so then the vertical component is going to be negative 500. And when I add all of those up, the sum is supposed to be 0, 0. Now what I can do is I can take each of the components, add them together, and then make them equal to 0. What I mean by that is this component, and this component, when I add all of them together, should give me a sum of the 0 value here. So let's go ahead and write an equation that helps us with that. So the magnitude of T1, cosine of 37 degrees, plus the magnitude of T2 times cosine of 145 degrees, plus 0 is equal to 0. So that is our first equation, and we can simplify this by subtracting 0 from both sides. So this would be an equivalent statement to T1 cosine of 37 degrees plus T2 times cosine of 145 degrees is equal to 0. Okay, so we have that equation there. Now what I'm going to do is I'm going to add the vertical components together, and they should all add up to a sum of 0. So let's do that. So the magnitude of T1 times sine of 37 degrees plus the magnitude of T2 times sine of 145 degrees minus 500 or plus negative 500, however you want to write that, and that's going to equal 0. Now I'm going to rewrite this so that if I add 500 to both sides, that's going to give me equaling 500 here. Okay, so essentially now what we have is a system of equations, because here we have two equations and two unknown values. The unknown values are the magnitude of T1 and the magnitude of T2. These are our unknown values, and we basically have a systems of equations here. And to make this a more digestible, if it helps you, you could always make the substitution and say that the magnitude of T1, let's call it A, and the magnitude of T2, let's call that B. So something that might look a little bit more familiar to you is we have A times cosine of 37 degrees plus B times cosine of 145 degrees is equal to 0. And then we have A times sine of 37 degrees plus B times sine of 145 degrees is equal to 500. Now, back when you took maybe an algebra or a pre-calculus class, from here there are a few different ways that we can solve a systems of equations like this. And you could use the elimination method or the substitution method, but what I'm going to do here is I'm going to set this up as a matrix.